kita Bbosa Science, kwano kwa beti science, dafu ya Bbosa Science, truth na beta, truth na omega, truth na alpha science.
The Science Foundation College enamave ku Lwejjinja ng'oyingira kilomita emu. Ssomero lya Dene Boarding ery'abawala n'abalenzi. Ku O-level tusomesa arts ne sciences ate A-level tusomesa sciences zokka. Omwana mulete ku The Science Foundation College. Ffe tusinga okusomesa sciences. Okumanya ebisingawo kuba ku 0753 8 27 09. The Science Foundation College, based on sciences and based for sciences.
Chemical properties of alkylhalides. 1. Formation of alkenes. Alkylhalides react with hot alcoholic potassium hydroxide to form alkenes. The mechanism depends on the type of alkylhalides. Primary alkylhalides undergo E2 mechanism, whereas tertiary alkylhalide undergo E1 mechanism. Secondary alkylhalide undergo either mechanism, either E1 elimination unimolecular or elimination bimolecular. Example: chloroethane. You reflux it with ethanol and potassium hydroxide, you get ethene. Mechanism: ethanol plus potassium hydroxide, you get ethoxide ion plus water. Then chloroethane reacts with the ethoxide ion to form alkene. The ethoxide ion uses the pair of electron to pick a hydrogen atom from the carbon next to the one carrying a hydrogen atom. A double bond forms. The bond between the carbon and a hydrogen atom breaks to get one hydrogen atom was removed to get ethene. Example 2. 1 bromo 2 phenyloethane will react with methanol and methoxide ion to form an alkene. You can pause, write a mechanism, and then compare your answer with mine. Then the mechanism: the methoxide ion will pick a proton from a carbon next to the one carrying a bromine atom. The double bond forms. Then the bond between the carbon and bromine breaks to form phenyloethane. To form phenyloethane. The mechanism is still described as E2 elimination by molecular, because the slow step involves the methoxide ion and then the bromo alkane. Tertiary alkyl halides. 2-bromo 2-methyl-propane will react with ethanol in the presence of potassium ethoxide to form methyl propene, to form 2-methyl propene, to form 2-methyl propene. The mechanism the bromine atom ion breaks off a positive charge goes to the carbon atom where the bromine ion had broken off. Then the ethoxide ion uses a pair of electrons to abstract a proton from the carbon next to the one carrying a positive ion. The double bond forms. Then you get 2-methyl propene. The mechanism is described as E1 because the slow step involves only one molecule or ionization of 2-bromo 2-methyl propane. Then it is an elimination reaction because we are removing a hydrogen atom and a bromine atom from these 2 carbon atoms to form a double bond. Example 2, 2-chloro 2-phenyl propane reacts with hot ethanolic potassium hydroxide to form an alkene. You can pause, complete, and then write a mechanism. So you should have got this. Two phenyl propene. Propene. Then the mechanism this being a tertiary alkylhalide, first loses a chlorine ion. Then a positive charge forms on a carbon atom that had lost a chlorine ion. Then the ethoxide ion uses a pair of electrons to abstract a proton from the compound. A double bond forms and we get CH2. 2. Reaction with potassium hydroxide or sodium hydroxide. They form alcohols. The reaction is SN1 or SN2 for the mechanism is SN2 for primary alkyl halide or SN1 for tertiary alkyl halide. For example, chlorophenyl methane plus calcium hydroxide and warm, you get phenyl methane. Then the mechanism, the OH ion uses a pair of electron to displace chlorine ion from the molecule to get phenyl methane. The mechanism described as SN2, because the slow step involves two molecules, the OH ion and then the alkyl halide. Example 2. You complete, write a mechanism, then you compare your answer with mine. I hope you have got ethanol. Hope you have got ethanol. The mechanism, bromoethane is the primary alkyl halide, so it undergoes SN2 mechanism. To get ether. Tertiary alkyl halide. Example, 2-chloro-2-methylpropane react with potassium hydroxide to form 2-methyl-propan 2-ol. To form 2-methylpropan 2-ol. The mechanism, this being a tertiary alkyl halide, will undergo SN1 mechanism. This one is the first lost. In the slow step, a positive charge develops on a carbon atom that has lost a chlorine atom. Then OH ion uses a pair of electrons to react with a positive charge to form 2-methyl-propane to form 2-methyl-propane-2-ol. Example 2, 2-bromo 2-phenyl-propane reacts with potassium sodium hydroxide to form potassium hydroxide. So you can pause, complete, and then write a mechanism. I hope you have got phenyl-propane 2-ol. Mechanism. This being a tertiary alkylhalide, the bromine ion is first lost. You get a positive charge. Then the OH ion uses a pair of electrons to react with a positive charge. To react with a positive charge, then you get phenyl-propane 2-ol. The reaction is important because it increases the chain length by one carbon atom. Primary alkyl halide. An example, chloroethane plus potassium cyanide will get propane nitrile. Mechanism. The cyanide ion uses a lone pair of electrons to displace a chlorine atom from the carbon. Then you get the chain has increased by one carbon atom. The mechanism is SN2 because the slow step involves two molecules, the cyanide ion and then the alkyl halide. Example 2, complete and then write a mechanism. You pause, complete, then you compare your answer with mine. I hope you have got mechanism. Bromophenylmethane the cyanide ion uses a lone pair of electrons to displace a bromine atom ion from the compound, then you get tertiary alkyl halide. For example, 2-bromo 2-methylpropane plus potassium cyanide, you will get mechanism. This being a tertiary alkyl halide will undergo SN1 mechanism. get that one. Example 2, complete and write a mechanism. You can pause, complete, and then write a mechanism before you continue. You should have got then the mechanism. This being tertiary alkyl halide, the alkyl group atom go, alkyl ion go, it gets a positive charge. Then the cyanide ion uses a lone pair of electrons react with a positive charge to form by repeating these mechanisms over and over, you get them. So through practice, you'll be able to know whether a compound undergoes SN1 or SN2. Watch this video over and over to get sense out of it. Formation of ethers, alkyl halide. Alkyl halides react with alkoxide ion to form ethers. Primary alkyl halide undergo SN2. Tertiary alkyl halide undergo SN1 mechanism. So primary alkyl halides. Example, mechanism. The oxide ion uses a pair of electrons to displace chlorine ion to form which is diethyl ether or ethyl S-oxide or ethyl S-oxide. Alkyl halide. Example, 2-bromo 2-methyl-propane will react with potassium S-oxide to form then mechanism. This being a tertiary alkyl halide will first bruise a bromine ion to form a positive charge on a carbon atom. Then the S-oxide ion will use a pair of electrons to react with a positive charge to form an ether. To form an ether. Coupling reactions. Alkylhalides will undergo coupling reaction in the presence of sodium and dry ether. Example: the chain length doubles. Then 2 so the chain length will double. The chain length doubles. 6. Formation of Grignard's reagents. Alkylhalide reacts with magnesium in dry ether to form Grignard's reagents. Example: generally, alkylhalide plus magnesium, you get a Grignard reagent of the formula RMgX. Grignard's reagents are important molecules that can increase the parent chain by unlimited number of carbon atoms in a synthetic reaction. Grignard's reagents are important molecules that can increase the parent chain by unlimited number of carbon atoms in a synthetic reactions. For instance, Grignard's reagent can be used to form carboxylic acid by reacting with carbon dioxide. Example: this Grignard reagent plus carbon dioxide, you will get an acid. The acid will have one carbon atom extra. So Grignard reagent, when they react with the carbon dioxide, you can increase the chain by one carbon atom. Grignard reagents can be used to form primary alcohols by reacting with methane. When we react Grignard reagent with the methane, we get the primary alcohol has got one extra carbon atom compared to that of a Grignard reagent. Compare that one of a Grignard reagent. Grignard's reagents can be used to form secondary alcohol by reacting with aldehydes. For example, this plus ethanol, you get the number of carbon atoms can be varied by varying the number of carbon atoms of an aldehyde. The number of carbon atoms added can be varied by varying the number of carbon atoms in an aldehyde. Ethyl magnesium chloride will react with propanol to form two methyl propan 2-ol. To form 2-methyl propan 2-ol. So thank you very much for listening. The next topic is going to be amine.
Omukyala kyakufumbira kyolya, omukyala kyakufumbira kyolya, naye lwaki mono ku muntu womala kuyomba, mono ku muntu womala kulwana, mono ku muntu wotujereka, lwaki wangana okulya mu kyalo, lwaki woza simalako olimba, olusi wogifumbira waba kulwaza, olusi wogifumbira waba wakyamu, omulungi atanabakanyiwa n'obutayoza kiba kikyamu, entikko y'omukwano kisenge, lwaki naye lwaki mono ku muntu womala kuyomba, mono ku muntu womala kulwana, mono ku muntu wotujereka, lwaki wangana okulya mu kyalo, ofumba okwagala lisaaki okunyuma, wange nsiba mu lisaaki, mondo okumukutandwawo, mondo okumunyima ntabuka, mondo okumuzima kuba, mondo okuwomerwa kiva ku mazzi, wetegekere muno, nfunira akaseera akamala, ozanyisa omutwe ogwanyumirwa, wagazanyisa mipiira nyumisa, zanyisa baluni, zanyisa amabeere, lusinyoka n'okuyonka anyumirwe, faayo omukwano gwagala kuyiya, ofumba ogwagala lisaaki okunyuma, wange nsiba mu lisaaki, bwe luba oluganda nsobola okuwasa omukyala abawuwo, njagala omukyala abaawo, betita yombayomba, betita nyiganyiga, betita ganagana, bw'oyagala akawunga abaawo, bw'oyagala omuceere abaawo, ennyimba z'omupiira asobola, anyumisa, nyumirwa omukwano gwe, mondo ku muntu womala kuyomba, mondo ku muntu womala kulwana, mondo ku muntu wotugereka. Lwaki mondo ku muntu womala kuyomba, mondo ku muntu womala kulwana, mondo ku muntu wotugereka. Lwaki